Good morning, students. How are you? I am Manoj sir from AP. Today I'll discuss number system part 2 video. Yes. So this is my second video on this chapter, number system, and today I'll discuss 4 points. First point is density of rational numbers and its proof. Second point is decimal representation of rational numbers. And third point is how to check a given rational number will give terminating or recurring decimal without division. And fourth point, how to express a terminating decimal or a recurring decimal in the form of P by Q. Yes, so these 4 points today I'll discuss. First, density of rational numbers and its proof. So what is density property of rational number? The density property states that in between two specified real numbers there exists at least one rational number. This is the density property of rational numbers. Is it clear? So now we'll prove this. I'll prove this theorem. But to prove we need Archimedean property. What is Archimedean property? First we have to know that. If x and y two real numbers, any two real numbers, and y is greater than x, so obviously y minus x will be greater than 0. So when y minus x greater than 0, according to Archimedean property, there exists a natural number small n such that 1 by n will be less than y minus x. Yes, 1 by n will be less than y minus x. So this is Archimedean property. We'll use this property to prove the density theorem. Is it clear? Now the proof is written here, but still I'll explain how we can prove the density theorem. Yes. So first I am taking two real numbers. Let two real numbers x and y such that x is less than y. That implies what? Y minus x greater than 0. Yes. Now according to Archimedean property, just now I told you, n belongs to natural number, then 1 by n less than y minus x. Yes. So this implies 1 less than ny minus nx. Yes or no? So that means the difference between ny and nx is greater than 1. Ny minus nx is greater than 1. So since the difference is greater than 1, so in between nx and ny there exists one integer, at least one integer. So if I consider that integer m, and that is the least or lowest integer, then the nx value will be less than m. Yes or no? And when nx is less than m, then nx is greater than equals to what? Now m minus 1. Yes or no? So m minus 1 less than equal to nx less than m, where m is the lowest integer. Yes. So now if I break into two parts, one part is this, and another part is this. Yes. So from here, x is less than m by n. Yes, x is less than m by n. So if I mark as 1, now from here m is less than equals to nx plus 1. That implies m is less than, again see from here, from this part we can write nx is less than ny plus 1, sorry, ny minus 1. It is ny minus 1. Yes, nx less than ny minus 1. So if I put here nx is ny minus 1. Yes. So from here we are getting m less than ny. So m by n less than y. So if I mark as 2, then from 1 and 2, what we are getting? X is less than m by n and less than y. So what implies it? In between x and y there is one rational number. Yes, so this is the density property of rational number. Is it clear? Okay, so now I'll discuss the second point. So density of rational numbers and its proof completed. Now I'll discuss decimal representation of rational numbers, and this is second point. What is decimal representation of rational numbers? The decimal representation of a rational number is converting a rational number into decimal number that has the same mathematical value as the rational number. Just form different, but mathematical value both have same mathematical value. And a rational number can have two types of decimal representation. One is terminating and second is non-terminating but repeating, that is recurring decimal. So we can represent a rational number in decimal forms in two ways. Is it clear? One is terminating, another is non-terminating but repeating, that is called recurring decimal. Yes. I can give one example of terminating decimal. Say if I take 1 upon 8, what will be its decimal form? To get in decimal form, we have to divide 1 by 8. Yes. We can follow the normal division process. 1 not possible, so you have to put what? 0 point. We can take for decimal point 10. Yes or no? Now 1. So 2. Now 20. That means 2, 16, 4, then 0 and 5. So 0.125. Is it clear? So 0.125 is the decimal form, and it is obviously terminating decimal because it ends at 5. Is it clear? Now to get the decimal form, I followed the long division process, but when the denominator is 8, in that case easily we can write down the value without any division. What is the technique? Now when denominator is 8, when you are dividing by 8, then no need to follow the long division process. You multiply by 125 the numerator number and put the decimal point from right side after 3 places, after 3 digits. Yes. So here 1 by 8. So 1 multiply by 125. 125. And I told from right side after 3 place, after 3 digits, insert the decimal point. So 0.125. Yes. So according to this rule, if I ask express 7 by 8 in the decimal form, so easily you can write what technique I told. Multiply 7 by 125. So 125 into 7. 7 5 35, 7 2 14 plus 3 17 and 8. So 875. And I told from the right side after 3 digits insert the decimal point. So 0.875 is the right answer, the decimal form, and we got without long division process. Yes, I think this part is clear. Now one example of recurring decimal. So if I ask to divide 2 by 3, then what will be the result? 0.6666 like this. So 6 is repeating digits, infinitely repeating. So it is called recurring decimal, and we can express the repeating digit by this way: 0.6 bar. See, this bar indicates 6 digit is repeating infinitely. Clear? So this is called recurring decimal, and this is terminating decimal. I think this part is clear. Now next point I'll discuss how to check a given rational number will give terminating or recurring decimal without division. Without actual division, how can you check the given rational number will give terminating decimal or recurring decimal? The rule is, first we have to check the denominator of the rational number. But before it, we have to check the given rational number, that is, which is given in the P by Q form, that should be in the lowest form. So this part is important. Before checking the denominator, first we have to see the given rational number, which is P by Q form, that is expressed in the lowest form or not. If it is not, first we have to express in the lowest form. Then we will proceed to check the denominator Q. If the denominator Q is expressed in the form of 2 to the power n or 5 to the power m or 2 to the power n into 5 to the power m, both, where m and n are non-negative integers, then we can say the given rational number will give terminating decimal. Is it clear? But if the denominator Q contains any other prime factor than 2 and 5, beside 2 and 5, if the denominator Q contains any other prime factor, then the rational number will give repeating and non-terminating decimal, that is recurring decimal. I think this part is clear. Okay, now I will discuss one sum. Example 1, express the following rational numbers in decimal form. Express the following rational numbers in decimal form. So 8 upon 125. So just now I told you here 125. 125 when denominator, then we can follow the trick, or we can complete the sum with actual division. But if we apply the trick, it will take less time. What is the trick? Now when denominator is 125, then multiply the numerator by 8. Previously I told when denominator is 8, then multiply the numerator by 125. But here reverse. That means when denominator is 125, then multiply the numerator by 8. And in the result, insert the decimal point after 3 digits starting from the right side. So according to this rule, 8 into 8, 64. And we have to put from right side after 3 digit decimal point. That means 0.064. See, without division, we can say the answer of 8 by 125 in the decimal form 0.064. Is it clear? Now, second sum, 2 upon 3. What with decimal form? So if you divide 2 by 3, 0.666, that is 0.6 bar. Is it clear? So this is the recurring decimal form. Now example 2. Without actual division, identify from the following rational numbers which one will give terminating decimal or which one will give recurring decimal. So just now I told, first you have to check the given number in the simplest form or lowest form. 37 and 25 already in the simplest form. Then we'll check the denominator, that is 25 here. 25 is 5 square. So here the denominator is 5 to the power 2 form, 5 to the power m form. So that means it will give terminating decimal. Terminating decimal. Clear? Now second, 45 upon 32. It is also in the simplest form. Further simplification possible? No. So now check the denominator 32, which can be expressed in the form of 2 to the power 5, and this implies terminating decimal. Now third sum, 63 upon 48. Is it in lowest form? No, because we can simplify by 3, cancel by 3, 21, and it is 16. So simplest form is 21 upon 16. That equals to 21 upon 16 means 2 to the power 4. So denominator is expressed in the form of 2 to the power n. So this implies it is terminating decimal. Terminating decimal. I think this part is clear. Now fourth sum, 77 upon 24. Yes, 77 upon 24. Is it in lowest form? Obviously it is in lowest form. So now 77 upon 24, 3 into 8, 3 into 2 cube. So what we are observing here, denominator contains 3 prime factor. So this implies it will give recurring decimal. Recurring decimal, not terminating, because the denominator contains the prime factor 3. Yes. So I think these 4 sums you understood. Now how to express a terminating decimal or a recurring decimal in the form of P by Q. So this part I will discuss now. So I have discussed point number 2, I have discussed point number 3. Now I am going to discuss point number 4. Yes. How to express a terminating decimal or a recurring decimal in the form of P by Q. So I'll explain it with example. Express the following decimals in the form of P by Q. 3 sums I have taken, one by one I will solve. First is 3.024. So it is a terminating decimal. So how can we express in the form of P by Q? To remove the decimal point, what I will do? 3024 by 1000. Yes. Now we will simplify it. Cancel by 4, 4 7 the 28, 2 22, that means 4 5 the 20 and 4 6 the 24, 756, and cancel by 4, 250. Yes, 756 upon 250. Again we can cancel by 2 and it will be 378. So 378 upon 125, this is the P by Q form. Yes. Now see here, if we multiply by 8, 8 8 the 64, 8 7 the 56 plus 6, that is 62, and 8 3 the 24 plus 6 30, that means 3024. So this answer is correct. Now second part, .34 recurring on 4 part, we have to express in the form of P by Q. So I will do this sum in 2 ways. First is descriptive method, second is shortcut method. The first descriptive method, what is the rule? First we will denote by x, the given recurring decimal by x. So that we can write 2.344 like this. Now what is that technique here? First we will multiply this by 100. Why by 100? Because after decimal point 2 digits here. So that's why we will multiply by 100. So 100x. Yes. So what will be it if I multiply by 100? 234.44. Now multiply by 10. Why 10? Because after decimal point, non-recurring how many digits? 1 digit. So that's why 1 1 0, that is 10, and multiply by 10, we are getting how much? 23.444, like this. So here main part is we have to check in 2 parts where the decimal part is same. 0.444, here also 0.44. So that means we can subtract now. So 90x, here 211. So x equals to 211 upon 90. But again we have to check further simplification possible or not. 1 plus 1 2 plus 2 4. So it is not divisible by 3. So this is the simplest form. This is the descriptive method. But now I will show the shortcut technique, how easily we will get the answer. 2.34 recurring on 4. The simple technique is you write the whole number, then subtract the non-recurring part. That means before recurring, what are the numbers? Subtract that, divided by, count on how many digits recurring is there. So many 9s you have to put. So on only one digit recurring, that is only 1 9. And then after decimal point, on how many digits non-recurring, that means one digit is non-recurring, that means 9 will follow 1 0. Yes. So 4 minus 3 1 and 23 minus 2 21. So 200 by 211 upon 90 is the answer, and see the same answer we are getting. Is it clear? So now the third sum, one 1.027 recurring on 27. 1.027 recurring on 27. So first we'll consider let x equals to 1.027 recurring on 27 means 1.02727 like this. Is it clear? So here first we'll multiply by 1000. So 1000x will give 1027.2727 like this. Now after decimal point only one digit without recurring, so we'll multiply by 10. So 10x will give 10.2727 like this. And check here, after decimal point both parts same. So now we can subtract. Subtracting, we are getting 990x, and this part is giving 7101, that is 1017. So x is 1017 upon 990. Is it in lowest form? I think not, because 7 plus 1 8 plus 1 9, so it is divisible by 3. So if you divide by 3, we are getting 3 3 the 9, 3 3 the 9, and 3 9 the 27 upon 330. I think again divisible by 3. So 113 upon 110. 113 upon 110, this is the P by Q form. Yes, this part is clear. Now I'll discuss example number 4. We have to simplify the following. How will simplify? 7 by 8 plus, this is recurring decimal. So if I apply the shortcut technique just now I taught you, 3145, the whole number 3145 minus, subtract the non-recurring part, that is 31, divided by, on how many digits recurring? On 2 digits, so 2 9s, and after decimal point one digit is non-recurring, so 1 0 here. So this equals to 7 upon 8 plus 990, and 5 minus 1 4, 4 minus 3 1, and 31. So 3114 upon 990. We can simplify more. We can divide by 2. 15, 30, that is 50, again 5 and 7. And here 4, 9, 49, 98 and 5. Since 5 is here, so I think not divisible by 5. 14, 4, 18 are here, 12, 17, 18. That means divisible by 3. We can divide by 3. 3 5 the 15 and 3 19 the 57. And here 16 3 the 48. This again divisible by 3, 17 3, and here 55. Yes. So 173 upon 55, the simplest form, 7 upon 8 plus 173 upon 55. So if you take the LCM, 8 and 55, LCM is how much? 440. 8 5 the 40, 8 5 the 40 plus 4, 440. Yes, so 55 multiplied by 7, 7 5 the 35, and 7 5 the 35 plus 3, 38. 385 plus 173 into 8, 8 3 the 24, 8 7 the 56 plus 2, 58, 5 carry, and 13. So finally we are getting in the denominator 440, and in the numerator we are getting 9, 8 plus 8, 16, and 14 plus 3, 17. So 1769 upon 440 is the final answer, and this is the simplest form. Clear? Now example number 5. Express in the form of P by Q. We have to express in the form of P by Q. So 0.04 recurring plus 1.44 and 44 recurring. So just apply the shortcut technique. Here 4 whole number and without recurring 0, that means 4 minus 0 upon 9, because on 1 digit recurring, and after decimal point 1 digit non-recurring, so followed 0, 1 0 here, plus here also 144 the whole number minus non-recurring number, that is 1, divided by 2 nines, because on 2 digit recurring, and after decimal point no digit and without recurring, so no zeros here. So finally we are getting 4 upon 90 plus 143 upon 99. We can cancel by 2, and here is not possible to simplify it. So 2 upon 45 plus 143 upon 99. Now we have to add these two, means we have to take the LCM of 45 and 99. What is the LCM? 99 and 45. So if I give 9, 11 and 5 here, so 55 into 9, that is 9 5 the 45, and 9 5 the 45 plus 4, 495 is the LCM value. Yes. So now 495 divided by 45 means 11. So 11 into 2, 22 plus divided by 99, we are getting 5. 5 into 143 means 5 3 the 15, and 70 plus 1, 71. Yes. So 715 plus 22, that is 737 upon 495, and this is the P by Q form. Is it clear? So I solved up to example 5, and students, I am ending my class here. I think you have enjoyed. Still, if you have any queries, you can contact me through my mail ID. Please follow it, manoj@tigps.in. You can contact me through this mail ID. Thank you, students. Have a nice day.